Hello students, so today we're going to look at solving exponential equations. Finally, a reason why we're learning about exponents and logs. So, what you're going to want to have on you, notes, calculator, or pen or a pencil, all those are going to be useful for today. So, to solve exponential equations, first thing you need to know the properties of exponents. So make sure you kind of know those off the top of your head. How to change to log forms. So, 2 to the 4th equals 16. You know that should be log base 2 of 16 equals 4. So kind of keep that in mind, how to convert back and forth. E to the 5th, we know that as log base E of 148.4 equals 5. So that's ln of 148.4 equals 5. Okay, so keeping in mind how E changes to ln. And then the change of base formula, which was log base A of B equals log of B over log of A. Keeping that in mind, remembering that we can do that way. So there's two different kinds of exponential equations that you may see. You'll see one with exponents on both sides, kind of like this. 2 to the x equals 32 to the x minus 1. And then you'll see one with exponents on only one side, kind of like 2 to the x equals 100. So we're going to look at both of those and see how to solve each of them, okay? So exponents on both sides. Think about making things equal. So I have 3 to the x equals 3 to the 5th. You're going to want to make sure your bases are going to be the same. Once you get bases equal, you're just going to set exponents equal to one another. So I have x equals 5. And that one's done. And you would understand 3 to the 5th does equal 3 to the 5th, right? No doubts about that. But what about one that looks something like this? 9 to the 2x equals 27 to the x minus 1. I don't have the same base, right? But can't we rewrite so we can get the same base? That's the thing I would like to think to myself. So 9 is 3 to the 2nd, right? So what if I would write as 9 as 3 to the 2nd and still times 2x? Because that 2x needs to stay there, right? Now, 27, that's 3 to the 3rd, right? So I can name 27 as 3 to the 3rd, x minus 1. Okay, I have like bases now. But you're saying, well, what are we supposed to do with that 2 and that 2x right here? You're going to multiply. So you're going to get 3 to the 4x, 2 times 2x, 4x, equals 3 times 3x minus 3. You're going to multiply that in, distributive property. So I have same base. Notice how I have the same base right now. So now I don't have to worry about that. I just need to worry about my exponents. So I get 4x equals 3x minus 3. Subtract 3x from both sides. I get 1x equals negative 3. I think that these are probably a little harder, just getting the bases the same. So always think, how can I get to have the same base? That is the question you're always going to want to ask yourself on these ones. Now, exponents on one side. You need to isolate the base and then change to log. So you're going to get stuck in exponential form. So you're going to go to log world. So let's get just this alone. I want this just all alone. So I'm going to add 1 first. And you're going to get 2 to the x equals 7, right? 6 plus 1, 7. I am stuck in exponential world. I can't get to x. So let's jump to log world. So that's log of 2, log base 2 of 7 equals x. Marvelous. I have gotten to that form. So now what I can do is do my change of base formula. So log of 7 over log of 2 equals approximately, I'll wait for you to do it on your calculator quick. I hope you got 2.81. I'm thinking that's what you should have gotten. Double check, make sure. And if you plug that back into your formula, you will get something around 6. You will not get a perfect amount just because we're rounding. So even though you're plugging in values, just kind of see, did you get something around 6? Did you get 5.9 or 5.97 or something that's very close to 6? What about this one? I need to solve for x. So let's subtract 5 first. So we're going to get 10 to the x equals 55. I'm stuck in exponential form. See, I can't get to this x, so let's go to log. So log of 10 of 55 equals x. I now need to do my change of base formula. So log of 55 over log of 10, and that is equal to 1.74 roughly. So we know x equals 1.74, and it does check out. You don't get perfectly 60, but you kind of get around 60, which is just good enough. Oh no, now we got to e. Don't worry, e is alright. He's just a base also, so we just want this at the end. So let's divide by 4. We're going to get e to the 2x equals 5/4. I'm stuck in e form now. Can't go any farther. So let's jump to log. So it's going to be log base e of 5/4 equals 2x, right? Log base e, remember, that is just a way to write ln. Always write it as ln. Okay, when you see log base e, always think that's ln. So then ln of 5/4, if you type that into your calculator quick, you should get 0.22 roughly after rounding. Divide by 2 to get x alone, so 0.11 equals x. And that does check out as well. Let's try one more problem here. So just remember, you need e to the x all alone. So first, let's subtract 1. Gives you 84. Still not done though. Divide by that 3. Get rid of everything that's not in the exponent of e to the x. So e has to be all alone by the end. 84 divided by 3, that's 28. So I'm stuck in e form. Can't get to that x. Let's go to log. So log base e of 28 equals x, which is ln of 28 equals x. So ln of 28 on your calculator, if you type that in quick, you will get x equals 3.33 approximately. And that does work out in your equation.
And that's the end of this video. See you later, Sabers.